Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 23 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this excellent series of video lessons. And in this class, we're using the Sunfounder Kepler kit for Raspberry Pi. Now, Raspberry Pi Pico, I should say. Now, most of you guys probably already have your kit, but if you don't, look down in the description. There is a link over to Amazon. You can hop over there and pick up your gear. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 22. What was that homework assignment? The homework assignment was to create a temperature and humidity project where you use the Raspberry Pi Pico W connected to the DHT11 temperature humidity sensor, and then to have a toggle switch where you can toggle between reporting in degrees Fahrenheit and degrees centigrade. And then the icing on the cake, the cherry on top, was to connect an LCD display so that you're not just having to get the display back on your PC, but you're getting something that is moving more towards a deployable, portable, mobile prototype. Okay, first of all, how many of you guys were successful? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, hopefully most of you guys were able to do it, because really I'd shown you how to use the DHT11, I'd shown you how to do a toggle switch, and I'd shown you how to connect up the LCD. And so now you're just building a more complicated project where you're going to have all this stuff going on at once and a lot more code. And so it's really not a whole lot of new learning, but it's learning to be very careful and deliberate about hooking your circuit up, and very careful and deliberate about your coding. Okay, enough of all this rambling on. Let's jump in and start getting this project done. Probably be good if I move out of your way. But what I've got here, really, this is my circuit here, and then this is the schematic of it. Really, if you guys are following along in this class, I think it was in lesson number 21, I told you you already had the you already had the Pico, the DHT11, and the push button switch all hooked up, and I told you not to take it apart. So hopefully most of you guys are already here. You guys that might just be not taking this class, but just jumping into the middle of it in this lesson, you've got kind of two choices. One is you can pause this video, and then the precise schematic is up here, and you can just build to that schematic. Or if you want me to walk you through it wire by wire, step by step, you can go back to lesson number 22, where I show you how to hook the LCD up, and lesson number 21, where I show you how to wire up the push button and the DHT11. But since I've already shown that and I have the schematic in today's lesson, I am not going to go and do the wire by wire build for you, and I hope that makes sense. But we are going to come in and we are going to start coding this thing up. We're going to start coding this thing up. So we're going to come over here to this view. We're going to have a little sip of our Go juice here. And now, ladies and gentlemen, are you prepared to code? Are you prepared to code? Okay, this one's going to be kind of a fun one. It's really something you just got to be a little bit careful of as you're putting it in, but it's not a terribly hard program. Well, we're going to be using those GPIO pins. So from machine, we are going to import pin, okay, like that. And then we are also going to probably want some delays in here, so we're going to say import U time, and U is the symbol for micro, and so this is like import micro time, kind of like micropython time is kind of what it is, but I don't like that. I don't like that nonsense, so I'm going to import it as time. So now I can just use my time.time, time.sleep, that sort of thing. And now we are going to be using the DHT11. So from DHT, import DHT11, being very mindful of case. The DHT11 library actually comes with the DHT library actually comes with the MicroPython install, so you don't have to install that one. But I do need to take just a second here and call up something that on our next one, what we're going to do is, let's see, give me just a second. I just got to kind of show you where to go. I've got to call it up so I can show you precisely where to go, because for us to use the LCD, you do have to load an LCD library, and I got to kind of show you where that is. And so let's take a look at this. I've got it now, so just take a second. Sorry, a more accomplished YouTuber would have had this up already. But never fear, here we have it. So I'll just pop it on over here. And so what I will need you to do is go to the most excellent www.toptechboy.com. And then you can use this happy little search icon here, this little green search icon. And then I hate this window auto size thing that they want to do. Okay, then what you want to search on is LCD 1602 display library, and you want to make sure to say for MicroPython, because I think I've got also just a Python library, and this one might be different. So you want to come to this page, LCD 1602 display library for MicroPython, and then down here is the library. You will come here and you will click, and then that is copied. And then what you would need to do is come back to Thonny, and you would need to paste that into Thonny, and then you would need to save this as LCD 1602 Pi. So you would say like file, save, LCD, lowercase, 1602.py, and you need to save it in the same folder. You need to save it in the same folder that your main program is on the Raspberry Pi Pico. So right when I say save, I'm talking about saving it to the Raspberry Pi Pico. And now when we go in and we write this program and we try to import that library, it will be there. I've kind of rambled on this, I'm sorry, but if it doesn't make sense, go back to lesson number 22 and I show you how to install that library. And also that page that we went to on the website, it has instructions of how to do it. So I've spent way too much time on that one step. So we are going to come on over here and we are going to get busy again. We are going to get busy again with our coding. Okay, so now what I'm going to do is say from that library we just created, LCD 1602, we're going to import uppercase LCD, like that, uppercase LCD. Now, we're ready to start programming this thing up, and let's start with the DHT11. So I'm going to say my data pin is equal to pin 16. Okay, that's GPIO pin 16. And why am I calling that the data pin? I'm calling that the data pin because this is GPIO pin 16 right here in the corner, and it is hooked up to the DHT11. So that is where I'm going to read the DHT11 from. Okay, now I need to set up the pin, so I'm going to say my pin, the object, is equal to pin, the method. And which pin are we talking to? Data pin. Okay, and then that is going to be a pin dot out. Okay, and then a pin dot pull down. All right. Now you might say, whoa, wait a minute. That should be an input. No, it's like what we're doing is we're activating this pull down resistor with this command. So with this command, I am activating the pull down resistor with this part of it. And then what we're going to do is we're just going to pass my pen to the LCD, and then that library is going to sort it all out. I think that is a little bit confusing, but that's the way you do it. You set it as an output, you pass it to the library, and the library does the magic to make it all work. Okay, so we need to create our sensor object. Our sensor object is going to be equal to DHT11. And then what are we doing? That object, my pen. We're not passing it data pen, the variable, we're passing it my pen, the object that we just created, okay? Sometimes it's not for you to understand, it's for you to just do it, okay, because this is the way that works. It was a little confusing to me. But I digress. Let's go on. Okay, so we've kind of got the DHT11 set up. Let's come in and work on our push button now. So we're going to say but pen is equal to 15 for button pen, short for button pen. And that is because we've got the button up here. We've got it connected over to this corner pin, which is GPIO pin 15. Now we've got to create our object. My button is equal to pin. Which pin? The butt pin. Okay. And then it's pin.in as you would expect this time. And then here we're going to do a pin.pull underscore up like that. Pull underscore up. So here we have made the button pin an input as you would expect, and we've also activated the pull up resistor. Now, if this doesn't make sense, go back to those several lessons that we did earlier in this series on toggle switches, okay? And I explain all of this ad nauseum there. Now we're going to want to create a toggle, and we're going to be toggling between temperature F and temperature C. And so I'm going to create a variable that's going to be kind of a flag variable. I'm going to say temp unit C, and I'm going to set that equal to true. All right. Now I don't need a temp unit F because this is the way you think about it. If temp unit C is true, I am using units of centigrade. If temp unit C is false, I am using units of Fahrenheit. So we just need one variable, okay? Now we're also going to need to keep track of this button, so I'm going to need to know the button state. So I'm just going to initialize this as equal to 1. And remember, when the button is up, it's 1. When you press it down, it's 0. But when you go through the loop the first time, you want to make sure that those variables have values. So I'm just going to set them to 1. And that way we don't inadvertently crash the program, that they're going to start out with a value. And I started at 1 just because, well, the program's just started. No one's had a chance of pressing the button yet. But I need to not only know the present button state, I need to know the previous button state. Because when have we actually pressed the button? Well, if last time through the loop the button was down, if last time through the loop button state was 0, and this time through the loop button state is 1, then that means we pressed the button. It sees that transition from pressed to unpressed. Boom. That's when we toggle. So I'm going to say the button state is 1. Then I'm going to just also say the button state old. That's what it was last time through the loop. I'll set that to 1, just saying not pressed now, had never been pressed when we first run the program. Okay, so we just initialize those variables, button state old and button state. And now I want to print just to my screen my sensor data. Get a little something there in the monitor for us to look at. And now I think we're ready to start looping. We're going to be looping. So I'm going to say while with a small w, while true. When is true? True. True is always true. We have created an infinite loop. Now the first thing we want to do is read where this button is. So I'm going to say button state is equal to my button, the object we created, dot value, like that. Okay, so right, we created this object up here, my button. Now we are going to read the value from that, and we're going to put it in button state. Now this button state is a real one now, not like just where we just stuffed a variable in there. Now this actually has a real value for where the button is right now. Okay, now what do we want to do? We want to toggle if what? If last time through, that would be if button state old, that's the last time through. If that was a 0, and if this time through button state is a 1, then that means we have pressed the button, and that is when we want to toggle. So I'm going to say if button state, what is this nonsense? I got stuff going on down there that's upsetting me. Sorry, I don't like those errors just sitting there for no reason. Okay, but I digress. If button state old, that's the last time through. If that's equal to 0, meaning it was pressed, and button state, the present one, is equal to 1, meaning it was released. That means it saw a press, it saw a released, time to toggle. It is time to toggle. So how are we going to toggle it? We're just going to say temp unit C is equal to not temp unit C. And when you look up here, temp unit C was set up as a Boolean variable, a true or a false. So what this means is that if we are in temp unit C, if we're in centigrade, temp unit C is going to be true, okay? And then if I press and release, it's going to make it not true, which is false, which means we're then going to be in Fahrenheit. If we're false and it sees a press down and a press up, then it changes the false to true, and then we're back to centigrade. And so this is a simple toggle switch. Now, what I like to do on this sensor, I was noticing when I let this thing run a long time, why does that thing have a value on it already? I'm not sure why that thing has a value on it already. Ignore that. It was a program that was already loaded in there is running, so we'll just power on ahead here. Okay, so now what I want to do is I noticed that if I ran this thing for a long time, sometimes the program would crash, like it would try to read the DHT and it wouldn't get a value back, and then the program would crash. So I'm going to do a try and accept, which means it keeps the program from crashing. It just tries it, and if it gets an error, it goes to accept and then moves on, so it doesn't stop execution of the program. So I'm going to try to do a sensor.measure like that. I'm going to do a sensor measure, and then what happens if it doesn't work, except I'll just pass. I won't do anything at all. Okay, I'm not going to do anything at all, but that just keeps it from crashing if it tries to make a measurement and gets hung up or something doesn't work right. Does that make sense? I hope it does. Okay, so now I can get the values. Temp C is what the sensor reports, and so that is just simply sensor.temperature, like that, sensor.temperature, like that. Now, it doesn't give you temp F, but we can calculate that. Remember back in your like 9th grade physics class, learned how to do this. I'm sure you forgot it like 5 minutes later, but now is your chance to use it. Temp F is equal to temp C times 9 divided by 5 plus 32, like that. Times 9 divided by 5 plus 32 will take us to Fahrenheit. And now we also want the humidity, so I'm going to say hum for humidity is equal to sensor.humidity. That'll run out and get the humidity from it. And then what I'm going to do is now I'm going to decide what I'm going to print and what I'm going to write to the LCD. Okay, so I'm going to say if temp unit C equal true. What does that mean? That means that I am in centigrade. And if I am in centigrade, then what I'm going to want to do, I'm going to print it to the screen, and I'm also going to print it to the LCD. So I'm going to have two print statements. So print, and what I'm going to do is I'm going to say the character. Is this a forward slash or a backslash? I don't know. I think that's a backslash. Just make sure you use this one. Make sure that you use this one like that. Okay, the other one doesn't work. And now that is saying what I'm going to print, I want to overprint the last line. And that way it doesn't scroll down in the terminal. It doesn't keep scrolling. It just overwrites that same line. So that R is telling it to overwrite. What do I want? Well, I want temp. And then I want an equal and a space, and then I close that string, and then what do I want? Temp F like that. And then now I want the little degree sign, How do I get the degree sign in the terminal? I print the character CHR number 176, and that is your friendly degree sign. Okay, and now I want to concatenate that with the character F. And then I'm going to put a space like that. And then what am I going to do? I'm going to print the string humidity like that equals space, close that string. And then what do I want? I want hum for humidity. Okay, I want hum for humidity. And then what do I want? I want comma, and then I want the character percent, like that. Okay. And now what I need to do is I need to end that overwrite. So end is equal to, and I think I am just going to put open close quotes. And so now I need to close that print. Okay, hopefully that's going to work. I probably made a mistake in there. Okay, and then what I'm going to do is now I've got it on the screen. Now I'm going to put it on the LCD. And how do I put it on the LCD? Pretty straightforward. I am going to do a LCD.write. And then what am I going to write? I'm going to write to column 0, row 0, and then I'm going to put the string temp like that, colon, space, and then close that string. I'm going to concatenate to that string the string value of temp. Man, this is temp C. Man, this is temp C. And this is temp C, like that. I was getting ahead of myself. Temp C. Okay. Temp C. And then I close the string conversion. And then I'm going to add, what do I want? I want that degree sign. But on the LCD, it's not character 176. We have to do it this way. We open a string, and then we are going to backslash. Okay, I think that's a backslash. But anyway, the one that's pointed that way, and a little x and a df, and then we're going to close that character, and then we're going to add to it the character F for degrees Fahrenheit. So this should give us the little degree symbol, and then this should give us the F for Fahrenheit. And then let's close that thing. Okay. And then what I'm going to do is I'm going to take this whole thing, I'm going to copy it, because really the Fahrenheit should be almost the same, so I'm going to paste it. But this time, if temp unit C is equal to false, that means that we are in Fahrenheit, and in that case we would want to print temp F, and then we would want this to be temp F to the LCD screen, and then here, oh, I did it again. This one up here should have been C for centigrade, right? So this is the centigrade loop, and this is the Fahrenheit loop. Okay, so now we are getting through this. This is a lot easier than you thought it is. I think the hardest part was just get the circuit all built. But we're almost there, boys and girls. All right, so now what we're going to want to do is let's go ahead and do a time.sleep, because we don't want to hammer this sensor too hard. So we're going to give it about 1/10 of a second to rest between readings. And now, very important, remember I've got that button state? Well, next time through, this button state, next time through is going to be button state old. So our nice, fresh, and crispy button state is going to now become button state old. It's now going to become the old one. Okay, so next time through the loop, today's button state, next time through the loop becomes button state old, if that makes sense, button state. Oh man, how many mistakes did I make in here? Button state, why is it highlighting button state? I don't know, hopefully I didn't make a mistake. A lot of times I get case errors because I don't get my finger off of the shift key fast enough. But what I am going to have you do, I'm going to have you hold your breath for me, okay? And if we all hold our breath, maybe this thing will work on the first run. Okay, we will hold our breath. Oh, denied. LCD isn't defined. What is this nonsense? Did I not set that up? Did I not set that up? What do you mean? Okay, I did not set that up. All right, so here I've got to create my LCD object, okay? I loaded the LCD library, but I've got to create the LCD object is equal to LCD, the method in the library. And you notice that we're not passing it any pin numbers or anything like that. And that's because I think the library is just hardwired. The library is hardwired for those GPIO pins. What were those GPIO pins that we used? Okay, I'll have to look. It was like pin 10 and 11. That was like GPIO pins 7 and 8, it looks like. Mm. 9 and 10. I think we used 9 and 10. So 9 and 10 are GPIO pins 6 and 7. And so I think the library is hardwired for that, for the LCD. And so we really don't have a way to go in and change that unless you go in and play around with the library a little bit. But you hook it up the way that I showed you. You hook it up the way that I showed you here. And if you hook it up the way that I showed you here, then everything is going to work. But you can't just come in and hook the LCD. With this particular library, you can't just come in and hook the LCD up to whatever you want. Okay, now let's come back and we're going to try to run it again. The real problem is one of you didn't hold your breath. I think you know who you are. This time I will kindly request you to hold your breath. Okay, giddy up. Giddy up. Look at that. Okay. You can't quite see it. Let me make sure that you can see it on the screen there. Okay, so what you can see is it is giving me a temperature of 29 degrees F and a humidity of 61%. Let's see if I can toggle it. And if I toggle it, 84.2 degrees Fahrenheit, 61% humidity. If I do it again, I've got 29 degrees F and 61% humidity. Now you notice now that after I toggle and toggle back, I've got 2 percentages, and that's because I'm overriding this line, and that percentage from the Fahrenheit reading where you have more digits is still there because it wasn't overwritten. And so what does that mean? That means when we come up here and we are doing the print, when we go to centigrade, we need to just put some spaces at the end like that. And now those spaces will write over anything that were there from the last time. So let's try it again. That's just a little thing. Okay, it wants us to kill the program and we'll try to run it. Okay, so 30 and 60, I'm going to press the button and release it, 84.2 and 60%, and no extraneous characters. All right, guys, that is looking really good. Now let's look over here. Let's look over here at more of the build view, and let's see, I need to kind of pop this thing up here so you can see if you see it there a little better, and then I try to get it all straight and neat. Okay. And let's see, want to make sure that you guys can see it. Okay, so it's 86F, and then I go to 30C. And now you can see 2 things. You can see that I have the same problem here of that centigrade being a shorter string, so it's not overriding that last line, which had the F in it. So we'll come back over here, and what I think that we can do there is that when we're doing the LCD right after this C, we can put some spaces, okay, like that. And now that should write over whatever was left from the right of the Fahrenheit reading. Okay, I hope that makes sense. So now that should fix that, but also what did we forget to do? We forgot to put the humidity in there. So let's come down and let's put onto the LCD display the humidity. Now I'm going to do an LCD.write, But this time I want to still be in column 0, but I want to be in row 1, which is the next row down from 0. And then what do I want to put there? I want to put humidity, colon space, and then I'm going to close that, and then I'm going to concatenate that with the string value of hum, okay? And then I am going to concatenate that with the percent sign, like that. Close that character, close the right, and I think we might be ready to go. I am going to stop this, and then I am going to run this. Okay, that's looking good, and look at that down here. We'll go to our more zoomed in view. We'll get ourselves a little sip of jet fuel here. Hey, I spelled humidity right too. That's always, I feel good when I spell things right the first time. Okay, so we're going to come in. I'm going to press the button, and look at that. We toggled to 84.2 degrees F, and then I'm going to toggle again, and we're going to go back to 29 degrees C at a relative humidity of 60%. So this is just pretty darn cool. Now, what I want you to look at here, let's see if I can let you look at this a little better without that other stuff in there. Okay, so if we look at this, what do we see? We're getting very, very close to a portable system. We're getting very, very close to a portable system. And what you got to see is the only thing that this cord is doing at this time, is providing power to this, okay? And so if we could just get rid of this thing, then we would have a completely mobile device, And so that's kind of where we're going in this class. I don't have a homework for you. You guys just make sure that you get caught up and get caught up to where I am here. And then next week, what we're going to do is we're going to start looking at how can we power this thing? How can we power our project without connecting it to the computer so we can get up and walk around with it. And what you'll see then is that right now, where do you get the input? You get the input from the button. Where does the output go? The output goes to the LCD. And so really, at this point, the only thing holding us back is just this cord. And so what we're going to do is I'm going to show you how to operate this thing off of a battery. And the good thing is off of a LiPo battery. And I'm going to show you how to kind of integrate power management into your project. And then the really cool thing is, yes, I've done this for the case of the DHT11, but once you see how to use that power module in the battery, then you can run whatever you want to remotely. Okay, you can run whatever you want to remotely because you've got the battery and you've got the display and you've got the input through the button, and then you can just, any project that you want, you can go completely mobile at that point. Okay, guys, I hope you are having as much fun taking this class as I am making it. If you enjoyed the class, give us a thumbs up. Also, you'll help us with the old YouTube juice if you'll leave a comment down below, maybe a little comment of encouragement down below. And then if you've not already subscribed to the channel, when you do, make sure you ring that bell so you'll get notifications when future classes drop. And then, as always, and most importantly, share this video with other people, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.